Hello students, welcome back to physics class. I hope all of you have gone through the previous videos and understood the concepts. Let's get started with our today's session. In the previous class we have seen about the concept speed and velocity. In today's class we shall see acceleration and deceleration. So let's see what is a speed. Speed is an indication of how fast an object is moving. For example, if you take a car is moving 5 miles in 30 minutes, then its speed will be 10 miles per hour. So next is velocity. The velocity of a body is the distance traveled per second by the body in a specific direction. Velocity is a vector quantity, and also we have seen uniform velocity, non-uniform velocity, instantaneous velocity and average velocity. Generally, bodies do not move with uniform velocity. The velocity of a body changes either in magnitude or in direction, or both in magnitude as well as in direction. For example, the motion of a vehicle in a busy market or while leaving or approaching a destination is with variable velocity. The motion of a planet or satellite in a circular path is also with a variable velocity. Now consider the motion only in a straight line path. Here there is no change in direction since it is going in a straight line path. Okay, and the change in velocity is only due to change in speed. In such a case, if the velocity of a body increases with time, the motion is said to be accelerated. While if the velocity of the body decreases with time, the motion is said to be decelerated or retarded. Thus, retardation is a negative acceleration. Let's see what is the acceleration. So acceleration is a rate of change of velocity with time. Thus, acceleration is numerically equal to change in velocity in 1 second. That is, we can write it as acceleration is equals to change in velocity by time interval. Okay. Let's see the unit of acceleration. So you know the formula, acceleration is equals to change in velocity by time interval. So unit of velocity by time. Then the SI unit of velocity is meter per second and the SI unit of time is second. Then the unit of acceleration will be meter per second divided by second, that is meter per second square. Next, relation for acceleration. Let a body be moving in a straight line in one direction with an initial velocity u. Its velocity changes in a short time interval t, and the final velocity becomes v after time t. So what is given? Initial velocity u and final velocity v, and the time taken is t. So the change in velocity, how will you find the change in velocity? That is final velocity minus the initial velocity, and the time taken is t. Then the formula to find the acceleration is change in velocity divided by time. So it is v minus u divided by t. So the formula to find the acceleration is v minus u divided by t. This can also be written as v is equals to u plus at. So if final velocity is greater than the initial velocity, then a is positive. Thus a is the acceleration. But if final velocity is smaller than the initial velocity, then a is negative and a is the retardation. Let's take example to understand acceleration and retardation. First one, suppose a car initially at rest, that is u is 0, and starting acquires a velocity of 20 meter per second in 10 seconds. Thus, the change in its velocity is final velocity minus the initial velocity. Final velocity is 20 meter per second and initially it was at rest. Therefore, the initial velocity is 0 meter per second. The change in velocity is 20 minus 0, that is 20 meter per second. This change has been brought about in 10 seconds. Therefore, the acceleration of the car is a is equals to change in velocity v minus u divided by t. That is 20 meter per second divided by 10 second. That gives you 10 ones are 10 twos are 2 meter per second square. So how it is meter per second square? So here you have velocity meter per second and time is second. So when you take this second to the numerator, again you will have minus 1, right? So it is meter per second square. Next, if a car initially moving with a velocity of 25 meter per second, that is initial velocity u is equals to 25 meter per second, is brought to rest in 5 seconds. So what is the final velocity? It is brought to rest. Therefore, final velocity will be 0 by applying the brakes. Then the acceleration of the car is change in velocity divided by time. V minus u divided by time. V is, since it is brought to rest, final velocity will be 0 and initial velocity is 25 meter per second and it is brought to rest in 5 seconds. Time is 5 seconds. So it is 0 minus 25 gives you minus 25 meter per second divided by 5 seconds. It is 5 ones are 5 5s are. So 5 meter per second square. This minus indicates it is retardation. So retardation is 5 meter per second square. So now you know what is the formula to find the acceleration. So what is the formula to find the acceleration? It is change in velocity by time interval. So you know that velocity is a vector quantity. Therefore acceleration will also be a vector quantity. It is represented by a symbol a vector. The direction of acceleration is the direction of change in velocity. For the motion in a straight line, the acceleration is in the direction of motion of the body. In today's class, we have seen acceleration and retardation. Your homework is solve this problem. A body starts from rest and acquires a velocity 10 meter per second. In 2 seconds, find the acceleration. So you know the formula for acceleration, that is change in velocity by time. So use the formula and find out the acceleration.